Today, we delve into the Garden Basics archive for 3 segments about the importance of feeding your soil, not your plants. We talk with America's favorite retired college horticultural professor, Debbie Flower, as well as Sacramento's organic advocate, Steve Zien. We explore the vital role of nitrogen in gardening. We address another listener's concern about low nitrogen levels in soil, discussing the challenges of measurement and alternative testing methods. We emphasize the significance of organic amendments, such as compost and cover crops, particularly with crops like fava beans and clover, to enhance nitrogen levels and overall soil health. Our conversation also covers the detrimental effects of high-salt synthetic fertilizers. We talk about sustainable gardening practices that promote nutrient cycling and plant growth. Today, it's episode 411, How to Fertilize Your Garden. We're podcasting from Barking Dog Studios here in the beautiful Abutilon jungle in suburban Purgatory. It's the Garden Basics with Farmer Fred podcast. Let's go.
Hello, Farmer Fred. My name is Joel, and I live in Fremont, California. I have a question about how to test for nitrogen in my soil. Recently, I sent several samples from my garden to a lab, which returned reports indicating low nitrogen. Thanks to you, I am aware that such reports of nitrogen are unreliable, and some other labs don't even report nitrogen. Do you recommend an alternate way to check for nitrogen? Would simply adding compost on a regular basis be sufficient to replenish the nitrogen without testing? Thank you so much for your information. I've learned so much from you through the years.
Joel, thank you for listening to the Garden Basics podcast. Appreciate it. Debbie Flower is here, America's favorite retired college horticultural professor. And Debbie, we have talked in the past about nitrogen and the fact that it's a very important fertilizer ingredient, but it's also very elusive too because it wants to be a gas.
Yes, it wants to be a gas, and it also, if it's in the soil, it moves with water, so it can quickly move out of the root zone.
So how do we solve Joel's issue here? I mean, measuring nitrogen, and I've seen a lot of soil reports, and Joel's right. They don't even talk about nitrogen because nitrogen is hard to measure unless it's really an overabundance of nitrogen. Then the report might mention it. But usually nitrogen is here one day and gone the next.
Right. With students, we used tests the kind where you wet the soil and take the water that's come off the top of the soil and mix it with chemicals to get the color. And then the color tells you how much nitrogen you have.
And those tests can be found at any nursery. They're called NPK tests.
Right. I like, yes. And I like the ones that are a little more sophisticated. I can't think of the brand at the moment.
Lamont.
Yes, I like the Lamont soil test kits. So I use those with students. So you can do that yourself. The instructions are pretty clear. The only thing you probably need is some deionized water, something that you wouldn't necessarily have sitting around your house, and the test kit. But they're not super expensive. They're not super cheap. They tend to have multiple tests per kit, and you can replace the reagents, they're called, the chemicals you need to produce the color. So if you're interested in checking your own nitrogen soil content, that is one way to do it. I did a little bit of research on the type of resin tests you used. They seem to be fairly new. And everything I found was an experiment by an academic institution testing whether they work very well or not. And everybody said they do. They work well. They explained how they work. And as long as the resin capsules are in contact with the soil the correct amount of time. I don't know what the directions were on the tests that you received, but one experiment I read about said if they're there not long enough, they don't tell you how much is actually there. They haven't accumulated it. And if they're there too long, the resin capsules have accumulated a lot of the nutrient, and then they start to give it back to the soil. So the amount they're reading will fluctuate depending on time. And so hopefully that was addressed in the directions you got on that soil test. The way I judge if I have enough nitrogen in my soil is the response of my plants. They will show nitrogen deficiency symptoms if there is not enough there. The classic nitrogen deficiency symptom is yellowing of old growth. So typically that's on the bottom of the plants. And that can occur for a number of reasons, nitrogen being one, but also shade being another. And this is critical, at the same time that those yellow leaves are falling off, you're getting new growth. So the plant is still active, but the leaves at the top that are forming are not getting as big as the other ones. You're getting small new growth. And that's because nitrogen is, as it is in the air and in the water, it is mobile in the plant. When the plant runs out of nitrogen in the soil, it will take it out of the oldest leaves that used to be in the sun but are now in the shade, and it will move it to the new growth. But it's not a super efficient conversion, and so the new growth isn't as big as the old growth that is being sacrificed for it. So that is the classic nitrogen deficiency. A general yellowing of the plant is also a classic nitrogen deficiency. So those are symptoms I look for. On the opposite end, if you apply too much nitrogen, you'll get incredible rapid green growth. You may lack flowers and fruit, and you probably will have an aphid population in your newest growth because the leaves are growing so fast the plant doesn't have enough energy to cover them with a waxy coating quickly enough to prevent the aphids from attacking them. So you can sort of, if you're very observant of your garden, you can sort of adjust, sort of figure out whether your plants have enough nitrogen or not.
Yeah, it's an interesting thing, too, especially about the new growth at the top, because most people are looking at the tops of the plants and not the bottom of the plants and may not notice the older yellowing leaves or think that's normal. But that definitely significant smaller leaves at the top. And sometimes they're a little bit distorted, too, aren't they?
Could be. They just can't grow as well.
Yeah. So that is something to keep your eye on when it comes to a nitrogen deficiency. And as you mentioned, the whole purpose of nitrogen is that green growth. Because with green growth, you get leaves. And with leaves, you get photosynthesis. With photosynthesis, you get more plant growth.
Right. More plant food. Yep.
Yeah.
So then the question was, can adding compost provide sufficient nitrogen? Depends what you're growing, I would say. If you're growing something and you're harvesting part of it, food primarily, or it's a cutting garden for flowers, something like that, you're removing enough stuff, enough plant food stuff that you probably can't replace the nitrogen need to continue that growing and harvesting just with compost. If you're growing trees and shrubs for nice ambiance in the landscape, then mulch is often sufficient. So it depends what you're growing.
A combination of mulch and compost, I think, is all a garden needs for most crops. But you're right. There are some crops that are heavy feeders, like corn. Here's a plant that gets 6 feet tall and uses a lot of nitrogen to get 6 feet tall with mostly green parts and maybe a couple of ears of corn, if you're lucky. You're better off, if you are growing corn in your garden, would be to rotate it through various points in your garden.
Yes.
On a yearly basis.
Yes, there are charts you can read, and I think Fred has posted one, a pie-shaped chart of rotating vegetable crops so that the heavy feeders like corn and cucumbers are maybe preceded by a nitrogen fixer like peas. And that's a way to add nitrogen if you are growing edible things, is to grow a cover crop, it's called, or it's sometimes called green manure, that fixes nitrogen. And that happens underground on the roots. And you cut off the tops of the plants before they flower, ideally, because a lot of the fixed nitrogen is used to produce the flower. For instance, fava beans for us in California, are a nice winter cover crop. But if we let them flower and produce beans, then we're not getting as much of the nitrogen left in the soil. The nitrogen left in the soil is on the roots of the plants, and it becomes available after the plant has died. So you chop off the top of the plant, ideally before it flowers and fruits. You can compost that, chip it and use it as mulch, whatever you prefer. But then the nitrogen underground becomes available. And then, of course, there's always fertilization. And you can fertilize with organic products. Manures have different amounts of nitrogen in them. Chicken manure tends to be one of what we call the hottest, meaning it has the highest amount of nitrogen. Don't use it unless it's been composted. My mother collected some out of her father's chicken coop. That chicken coop hadn't been used for 40 years. Chicken manure had been just sitting there dry. She put it on our vegetable garden and killed everything. Okay, you got to compost it. It's too hot, too much nitrogen in it. But you can buy composted chicken manure in bags that has some nitrogen value. You can buy pelleted chicken manure in bags that has good nitrogen availability. And of course, it's renewable. There are chickens that are pooping all the time. And you can buy steer manure. It is not nearly as high in nitrogen. You can buy fish emulsion, which is made from fish and has a nice, gentle amount of nitrogen, and some micronutrients, which are critical in plant production as well. So there are some more renewable, non-synthetic sources of nitrogen that are good for the producing garden when you're cutting and removing fruit or flowers or what have you, and need that higher amount of nitrogen.
A cover crop is a great thing to put into your nitrogen replenishment gardening mode, definitely. And like Debbie says, is you got to chop those plants up as soon as you start seeing flowers appear, because you want the energy going to the soil root area where the nitrogen is, as opposed to sending it off to develop flowers and seeds. So by cutting it down in little bitty pieces before it completely flowers, at least before 50% of it flowers, you're going to be helping out your soil a lot. From what I understand, I guess you could just chop it up in little pieces and leave it on the surface, although I've heard of people doing that, but I think that would allow a lot of nitrogen to escape from the top.
Right, you want to bury it, cover it with mulch, yes. Yeah. Right, nitrogen becomes gaseous, or just dig it down into the soil.
Mm-hmm.
With a broad fork might allow you to do that, because it can create, broad fork is like a big garden fork, a garden fork being the stiff one with, 4 or 5 tines?
4, yeah, usually. Yeah.
But a broad fork can be 3 feet long, 4 feet long, however wide your bed is, and it has many tines, and you just plunge it into the soil, rock it back and forth. You get a little opening. You can throw stuff in there, and then you move over a few inches to do it again. That closes the opening you just made and makes another one where you can put in more.
A little bit goes a long way, too.
Yes.
That's my big problem with synthetic fertilizers, is there's usually way too much nitrogen that the plant will never get to.
And it becomes pollution.
Exactly, yeah. And there are a much more slow release nitrogen fertilizers on the market these days. I know out at the Fair Oaks Horticulture Center, they like to use this chicken poop based pellets.
Right. And I bought a bag of that. It's not
Nutri-Rich, I believe.
Yes,
it's called.
Right. Costs a pretty penny, but it goes a long, long way.
What is the application rate?
I can't tell you off the top of my head. Yeah. I could look it up.
Well, maybe, if it's there.
Nutri-Rich fertilizer pellets. Use 500 to 800 pounds per acre.
All right. Well, now you have a 8x4 garden.
It says 8 to 12 pounds per 100 square feet. Yeah, it's not a very heavy application rate.
8 to 12 pounds per 100 square feet.
Right.
Okay. Yeah, that's not bad.
So I have about a third of that.
Yeah, and you work it in. You don't just lay it on the top.
I work it in shallowly, and then I rely on water to move it down.
Okay. Yeah. Fish emulsion, an old standby for a low nitrogen fertilizer that works because it slowly breaks down. A lot of people like worm castings too. I would put that into your mix for replenishing the soil as well. And you're right, that broad fork does a great job of opening cracks in the soil to allow you to just pour the worm castings into there.
Yeah. You don't have to go real deep because nitrogen moves with water. Water's applied at the top and it goes down through the soil. So it'll pick up the nitrogen near the surface and carry it down through the soil.
Yeah. A word about mulch. A lot of people like to use bark. They call up the sand and gravel place and have 10 yards of chips delivered, for example. And all those chips are the same size. And a lot of them are big. And it takes a long time for those to break down to feed the soil.
Mm-hmm.
Whereas your local tree company, when they're to go out and chop down a tree, they're not just chopping the tree, they're chipping it and shredding it and blowing it into the back of their truck. And there's no reason that truck can't stop at your place and dump it off in your driveway. And it's all different sizes. And as the smaller parts work their way in the soil, it's feeding the soil, but the bigger parts are still on top. And they're protecting the little stuff and protecting your soil from rain as well.
Yeah, it's good stuff. I have very black, rich soil. It's gotten to the point because I apply arborist chippings regularly, not yearly, every 2 or 3 years, I'd say. But I always have a pile in my yard because I'm always doing another corner.
Yeah.
It's gotten to the point where I can't grow some plants that like lean soil because I have my soil.
You've spoiled the little
Yes.
so-and-so. I would like to make an argument for using shredded leaves, the leaves that fall from your trees in the fall, especially your oak leaves. And I like to run them over with a mulching mower or stick them in a metal trash can and chop them up with a string trimmer, and then just pour it on top of my raised beds, 4 inches, 6 inches deep for the entire fall and winter.
And I think that's a better choice for the vegetable garden than wood. There's evidence that when we mulch with wood, which the arborist chips are, the biology in the soil favors plants that are woody. When we mulch with leaves, which are herbaceous, although fall leaves fall into the woody sort of category, the high carbon category.
Is it green or is it brown?
Right.
I've had that argument for years.
Right. The biology in the soil tends to favor plants that are herbaceous, which most of our vegetable crops are.
And ideally, if you have a healthy garden, would be to get yourself a little chipper shredder and shred up those plant parts too and use that as a mulch.
I just got one for Christmas.
Did you?
Yes, an electric one.
Oh.
And I used it at my son had one and I used it at his house and it was so easy and it produced nice little chips. And
did you try using green material in it?
I didn't.
Okay.
I didn't. And I'll have to do that when I go home and it stops raining. Yeah. So I asked for one for Christmas. My son lives in Minnesota, so I can't borrow it, but I asked for one for Christmas and I got it.
Congratulations.
Thank you. I'm all excited.
Yeah, that's really, everybody should have a chipper shredder.
Yes.
Yes, because we all have green waste.
Yes.
And there's no reason that green waste, and the healthiest green waste you can apply as long as your plants are healthy is the ones that you have in your own yard as opposed to some strangers.
Right.
Compost from whatever.
Yes.
Or mulch from wherever.
That is, the arborist chips sometimes bring you surprise plants.
Yeah, especially if they chop down a liquid amber tree. Yeah. All right. So there's that. So, Joel, a good question about nitrogen, and there are plenty of ways to keep it replenished, but you just have to keep at it.
And so interesting to hear your curiosity. I love it.
Yep. Thank you.
You're welcome.
I was thanking Joel. Don't feed your plants, feed your soil instead. You know, in past episodes, we have gone deep into what makes for a successful plant, and much of that success is soil related. The soil and all those beneficial critters that are in the root zone. And the better you treat the beneficial critters in the soil, my next guest says, the healthier your plants will be, because it's all about the soil. So let's turn it over to the Sultan of Soil, the Duke of Dirt, the Mayor of Mycorrhizal Activity, soils expert Steve Zien. How about helping us get our garden off to a good start?
You mentioned that there's lots of critters living in the soil. And if you have what's called a healthy soil, years ago, gardeners wanted that loamy soil. We have now learned that what we really want is a healthy soil. The healthy soil is alive with all of these microbes that you just talked about. I'll give you an idea of how many there are. In a teaspoon of healthy soil, you will find 8 billion microbes. And they're all there helping your plants obtain moisture, obtain nutrients, fight off pests, create a wonderful living soil condition that is more favorable for plant root development. And then versus if you've been using synthetic fertilizers and pesticides, rather than 8 billion microbes, you might find, maybe 50 in that teaspoon of soil. So how you manage that soil is so very, very critically important.
Well, let's talk about one of your favorite products, the blue crystal fertilizer stuff. I'm being facetious, of course. But what happens when you take synthetic fertilizers and pour it around the ground? What is the process by which that stuff does good or does not do good?
Well, there are two major problems with synthetic fertilizers. One is salt. They're very, very high in salt. And salt is a dehydrating agent. It sucks the moisture out of anything and everything it comes in contact with. There's a thing called what's called fertilizer burn. When you put too much synthetic fertilizer down or you don't water it in enough, the salt content will be so high it will actually suck the moisture right out of your plant roots and kill the plants. Or if it's not quite that bad, it will cause the plants to wilt. Now, if it can do that much damage to a plant, imagine what it's doing to these microscopic organisms that are, made out of one cell or just a few cells. It sucks up all of the water and kills them all. These synthetic fertilizers that are high in salts are destroying almost all of the soil biology. Now, the other main issue with these synthetic fertilizers is they're water soluble, which means when you apply them on the ground and you irrigate or water them in, if there's any runoff, because they dissolve in the water, most of that fertilizer is going to run off the lawn, go across the curb into the gutter, and directly into our creeks and streams. Also, because it's water soluble, when you irrigate, the little bit that does go into the soil, every time you irrigate, it's going to be pushing that fertilizer right past the root zone. And because there's no soil biology, these fertilizers, these synthetic fertilizers, have to be right next to where the roots are. And so if you've got a fertilizer, let's say it's got 33% nitrogen, and you put that down, you water it, you irrigate it following label directions, some of it's going to run off the soil surface. And so that amount of the fertilizer is gone. The material that moves into the soil, while it's still there next to the roots, most of that fertilizer is in the soil that is not close enough for the roots to absorb them. And then the fertilizer will then, with subsequent rain or irrigation, move right past the root zone. And so that 33% nitrogen, some of it's running off, some of it doesn't even get close enough to the roots to get absorbed, and the rest of it leaches beyond the root zone. So even though you've got 33% nitrogen, the amount that's actually getting into the plant is about 1 or 2%, if that. So it's not very efficient. Everybody thinks that with these big numbers, they're going to get more bang for their buck than the organic fertilizers, but that's really not the case.
Sounds like you're trying to blow a hole into my statement that plant roots aren't straws. It sounds like what you're saying is that in order for that fertilizer to work, it has to be right on top of the roots for the roots to absorb it. I always thought there was some sort of process going on down there that is converting those synthetic fertilizers into a more usable form for the plant.
If you're using organic fertilizers, that's exactly the case. So you've got an organic fertilizer, might have 5% nitrogen. It's low in salt. It's not very water soluble typically. And so when you put it on the soil surface and water it in, some of it's going to go in there. Sometimes the worms and the biology will have to work that material into the soil, and it's feeding the soil biology. The soil biology eat that material, and then through what's called the poop loop, change those nutrients into forms that the plants can utilize. And some of these microbes, for example, the mycorrhizal fungi, which have long strands. You can get miles of these strands in a thimbleful of soil, and they actually attach themselves to the roots and then go off large distances, depending upon whether it's an annual plant or a perennial or like a tree, and they extend the area that root system can now absorb nutrients. And it gets to the point where there's no place in the soil that's not full of this soil biology that can take the organic fertilizers, the compost, the worm castings that are filtering down into the soil and provide it to the plant. So that if you're using an organic fertilizer, has 4% nitrogen, almost all of that is going to get into your plant. So you're really getting more bang for your buck with an organic fertilizer. I think it's very helpful to do a soil test in the beginning and fertilize appropriately so that if you might have toxicities, you might have deficiencies. And if you get things in balance at that point, then really all you need to do is keep adding compost, mulch, and worm castings. I'm a firm believer in worm castings. And you don't mix them in with the soil. You don't want to disturb the soil. You just put them on top. Every time you disturb the soil, you are killing soil biology and you're setting it back. You're destroying what's called soil structure. And really, that's one of the goals that a gardener and landscaper should be doing, is trying to create soil structure, in particular if you have a sandy soil or a clay soil. What structure is a variety of different sized pores in your soil. And you want large pores and you want small pores. The small pores and the medium-sized pores hold water. The large pores are important because that's where the roots go, moving through. That's where the worms move through. But also after you irrigate or after it rains, those large pore spaces, the water in those large pore spaces will get sucked out of there and down by the force of gravity so that you have air in your soil. It's amazing how people water too frequently, filling up all of those pore spaces. They think, oh, my plant needs water. We've got to realize our plant roots also need oxygen and air. And so you need those large pore spaces. And the way you get that variety of pore spaces by creating soil structure is you don't till it because that destroys the soil structure, but you encourage the beneficial microscopic organisms. The bacteria, for example, exude glues. They're little one-celled critters. And if they didn't glue themselves to the particles of soil, every time it rained or you irrigated, they would get washed below the soil, out of the root zone. So they glue themselves to the soil particles. They produce enough glue so that the sand, silt, and clay particles and pieces of organic matter get glued together to form aggregates, creating that variety of pore size spaces. You also have things like fungi, which are just a bunch of fun guys and fun gals that are like long threads, and they're tying the soil together to create structure. So you really need to do everything you can to encourage these microscopic organisms. There are other critters that help with this as well, but those are the two major players that create soil structure.
We're talking with Steve Zien, soil pedologist, owner of Living Resources Company, about soil and the benefits of adding mulch and compost to your soil. Two things we learned from Debbie Flower on her recent appearances on this program in talking about soil include the benefits of mulch, and that mulch has a benefit that I didn't realize before. It stops the rain from destroying those soil particles, that the force of rain hitting bare soil can compress the soil, removing those pockets of air. And by keeping a few inches of mulch on top, it takes the hit for the soil from the rain and thus saves the air spaces in those soil particles.
It's called raindrop impact. My guess is you can probably go on the internet and do a search and search for raindrop impact. But the amount of force a single raindrop has, or a drop of irrigation that's flying across the air, can, when it hits the ground, can move a soil particle 5 feet in the air and 5 feet away from where that impact was. It's a huge amount of force. And what it does is it takes those clay particles and it moves them around in such a manner that all the pore spaces that were on that surface of the soil, they get plugged up with all these fine clay particles, and you get this really slick crust on top of the soil surface that doesn't allow air, doesn't allow water, doesn't allow fertilizer to move through. And so a lot of times when I talk to people about putting mulch down, if it's on bare soil, I suggest that they take a metal garden rake and just lightly rake the surface of the soil to break up that surface crust, because you probably have that surface crust, and it's really important to break that up. And then you will maximize rapidly the benefits of that mulch. Yeah, and also if you have a slope and that raindrop impact hits bare soil, that's how you get erosion. It's gonna loosen all of those soil particles from that impact, and they will move down the slope.
The other thing we learned from Debbie Flower, and we learned it from you as well over the years, is the fact that you don't want to be walking on your soil because that can compress that soil and also destroy those air pockets.
Well, you can walk on your soil, but you want the soil moisture content when you walk on it to be moist. You want to stay off of your soil when it's wet. It's highly subject to compaction when you walk on a wet soil. And then you're destroying it. You're making it hard for your plant roots to grow. You're making it hard for the soil biology to function. You are eliminating most of, if not all of those large pore spaces. So you're creating a soil that doesn't breathe very well, that has, when you irrigate, it has a lot of moisture, has very little air. So then you're likely to start having root disease problems. So yeah, you really need to stay off the soil when it is wet.
What if you have a few inches of mulch on your garden? Is it okay if you've got the mulch on the garden to walk over it?
And again, if the ground, if you just irrigated and that ground is really, really wet, I would try and avoid it. The thicker the mulch is, though, the less impact that walking is going to have on that, less compaction there will be. So if you've got, 6 inches, 7 inches of a wood chip, where you've got a wide variety of particle sizes and you've got, some really nice large pore spaces, they will absorb quite a bit of that pressure from your weight.
Recently, I was talking with Emily Murphy, author of the book Grow Now, and she made an interesting statement, and I've seen things like it from others, and I would like to get your impression of this. She was talking about the different mulches to use, and she said, if you're growing woody materials like trees and shrubs, use a woody material mulch like chipped and shredded tree branches. If you're growing a vegetable garden, you want to use mulch made from basically food, say like worm castings. True or false? Yeah. Can I put chips on my vegetable bed?
You can, but the reasoning is that when you put down wood chips, those wood chips are going to decompose. Wood chips typically have numerous different sized particles, from really, really tiny particles that are going to move into the soil relatively quickly. And they've got bigger ones that are going to last for a longer period of time. That material will feed the soil biology the best that is associated with woody materials. It's food for the biology that work in association with woody plants. And so it's really, really good to put down wood chips around plants that have, woody stems, trees, shrubs. With the vegetable garden, you can certainly put that down but you would also want to put down things like worm castings, compost, and the worm castings and compost typically are leafy type materials that have been composted either by the composting process or by the worm's intestines. And it will be more suitable, and it will encourage more of the appropriate biology in the soil for those kinds of plants. And so, yeah, the kind of mulch you put down would be best if it's appropriate for the soil biology that will work best with those kinds of plants that you are trying to grow.
Can I suggest a Solomon-like compromise here and perhaps put down compost or worm castings first on your vegetable bed and then top that with a few inches of a woody mulch?
Yeah, I think that's fine. And that will allow you to if you're walking on those areas, there's going to be less compaction, like we talked about just a few minutes ago. I mean, any kind of organic matter is going to be helpful. Just realize the kind of organic matter you put down is going to encourage particular varieties of microscopic organisms that work better for different kinds of plants.
What about colored mulches? Those are widely available now. Are good or bad for a garden?
Well, I think the big thing is, what is the source of the color? And are those dyes or paints potentially toxic? Rather than, the colored materials like that, which are typically bark and not wood chips. Wood chips are a far superior material. The bark and those kinds of colored materials, typically they're only one size. They're large because they don't have any small particles. They're not going to break down very, very quickly at all. And so they're not going to be nourishing the soil very much. And that would be the advantage of the wood chips, is that you have that variety of particle size, and it starts immediately beginning to feed the soil biology.
So explain the difference between a bag of bark and a bag of wood chips.
A bag of bark is, just big hunks of bark from your trees. And they're probably an inch in diameter, maybe a little larger, maybe a little smaller. And there's no fine, particle sizes in there. They're just going to sit on the soil surface. And, there are benefits to that, but they're not going to nourish the soil. They're not going to feed the soil biology. When you put down wood chips, when they grind those things up, they're typically grinding branches, big branches, small branches, lots of vegetation. And so the range in particle size is exceptional. And those small particle size materials are going to start nourishing and feeding the soils. By having small particle sizes on the soil surface, it will encourage worms to come up, feed on that material every night, and then go back down in the morning. And they will act as Mother Nature's rototillers in keeping your soil loose by creating channels for root growth, for water to move through. And you're not going to get that benefit from hunks of bark.
It's amazing. You mentioned the worms that come up and they'll feed on that chipped and shredded mulch that's breaking down and helping to feed the soil. What does that breakdown of that mulch do to the mycorrhizal activity? How is that impacted? Is that a big help to increase their populations?
Most certainly. That's the carbon in that kind of material is the food source for all of your beneficial microscopic organisms. They are not like plants. They don't have leaves up in there that can use the sun to manufacture food. They've got to get all of their food from or almost all of their food from organic matter. And so that organic matter, when it's small enough where they can act on it, they will exude chemicals that will help break that down, and they will feed on it. They will then make that material available through what's called the poop loop to your plant roots.
Are you going to explain that or just leave that hanging there, so to speak?
Okay, the poop loop. Most people think of the poop loop as nutrient cycling. As a soils pedologist, one who studies soils out in the real world, we call it the poop loop. And basically what the poop loop is you have this huge nuclear power plant up high in the sky. It's called the sun, and it's beaming down energy onto the plants. And the plants, through the miracle of photosynthesis, take carbon dioxide out of the air, put it into their bodies so that organic matter has all this carbon in the leaves and in the stems and in the roots. And then the plants breathe out oxygen so that all of the animals on the planet have oxygen to breathe. So then you're getting all that organic matter. Then that organic matter, in many cases, dies at some point, and then it's fed on by the decomposers, primarily the bacteria and the fungi. Bacteria and fungi are very efficient feeders. They take all of that nitrogen that was in that organic matter and they store it in their bodies. And so they're storing it like bags of fertilizer, okay? Then these microscopic organisms, the bacteria and the fungi, are eaten by small little microscopic soil predators. And they are not very efficient at using nitrogen. And so they've got to get rid of that excess nitrogen. And how do they do that? They poop. And that nitrogen is in their poop is in a form perfect for plant roots to absorb. And then those microscopic critters that are feeding on the bacteria and the fungi, they're eaten by bigger guys who are eaten by bigger guys who are eaten by bigger guys. And as you go up that chain, their efficiency of using nitrogen goes down. And so they end up having to get rid of that excess nitrogen. And so they poop, and that poop looping goes on. These predators are basically like fertilizer spreaders. And they are taking that stored up fertilizer in the bacteria and the fungi, and they are spreading it around the soil in a form that the plant roots can absorb. That's why Mother Nature doesn't have to add fertilizer. That's the poop loop.
Somebody may be wondering, well, then it's okay then to add my animal poop to my compost pile.
I would say no. I think it depends on the animal. I think it's the meat-eating animals that you really want to avoid. And that's primarily due to the possibility of diseases that can go from the animal poop into or on the produce that you will eat, and then you will be ingesting those spores from those potential diseases that can cause you health problems.
Anything else you want to add to this?
Enjoy the poop loop.
Okay. Thanks so much.
It's been fun, Fred, as always. Thanks.
We like to answer your garden questions here on the Garden Basics podcast, and I always like to bring in the big guns to answer the questions here, and that would be Debbie Flower, college horticultural professor, retired, who knows a lot and is willing to share it with us, and we appreciate her presence via the telephone to help us with these questions. And Debbie, Marion has a question about her string beans that are on a trellis that she says they're doing great, except I have had only 5 string beans. I don't think that's doing great. She says there are flowers all over. She mentions using a fertilizer. I won't mention the brand name, but in my mind, it's always a miracle if anything grows with this fertilizer because there's just so much nitrogen, phosphorus, and potassium in this particular water-soluble fertilizer.
A lot of salts. And if we put too many salts are charged particles. If you put ions, plants absorb their nutrients as ions. You put too many, actually a salt is something that dissolves in water. That's a definition of salt. But plants absorb their nutrients as ions, which are charged particles. And if you put too many salts, too many nutrients in the soil of that contains plant roots, plants can't absorb the nutrients. There's so much salt that they actually ooze their contents of their vascular system out into the soil. The whole direction of movement of water reverses, and the plant puts the water out into the soil instead of absorbing it into the plant. That's a process called osmosis. If you're making a cucumber salad, sometimes the recipe will say to slice the cucumbers and put them in a bowl, add some salt, and let that mixture just sort of sit for about an hour. And then you come back and you'll find that there's a puddle of water under the cucumbers, and that is the osmosis process working, where the salt on the outside of the cucumber causes the water in the cucumbers to come out, and you pour that off, and then your salad is less mushy. That same thing can happen around plant roots with what we call high analysis fertilizers where the numbers on the bag are double digits.
Are you suggesting that if you use these high energy fertilizers that have double digit NPK in them, that after fertilization, you may want to water the plant again to push that fertilizer down?
Well, you certainly don't want to apply them too often. You don't want to mix them any more concentrated than the directions recommend. In America, we often think a little is good, a lot is better, and that is not true with fertilizer. If it says a tablespoon per gallon, then don't do any more than a tablespoon per gallon. In fact, it's much better if you do less. Apply it only to wet soil, so water first. Apply only as much as is recommended or less, and apply it only as frequently as recommended on the label or less frequently. You and I have often used the term weekly, particularly for containerized plants that don't have the opportunity to send their roots long distances and collect nutrients from afar. But if you are fertilizing your vegetable garden, the same would apply there. And it means fertilize every week and do it with a very low concentration of fertilizer. So less fertilizer per gallon of water than is recommended on the label. So that's the other kind of weak, W-E-A-K. So weekly. But yes, if you've applied it and it's just, you haven't done any of the things recommended, absolutely add some water to dilute it is your goal. You don't want the fertilizer very strong.
I'm just wondering how many people actually use the measuring device that's included in those fertilizers.
That can be a problem.
Yep.
And when the analysis is very high, double digit, then you're setting yourself up for problems.
Well, now, one of the more common formulas for a water-soluble synthetic fertilizer, and this one particular brand we're talking about that was used on these string beans, their all-purpose plant food has an NPK, a nitrogen, phosphorus, potassium content of 24, 8, 16. I like to see that 8, that's for sure, because there's a lot of phosphorus around, and it's just wasted if it doesn't get used up by the plant, and can end up heading for streams and other waterways where you don't want it to go. But
Right.
that 24% nitrogen, I just don't understand why you would feed a plant that much nitrogen when it would be very happy with, say, 5%.
Right. 24, it's not 30, but it's still a very, very high number. And in general, the only place I could see using something with that much nitrogen is if I were in a production greenhouse and I had a schedule to produce a plant in a very quick time. And then I would be babying that plant. I would be, the environment has to be just perfect. The pest control has to be just perfect. Because with that much nitrogen, you're going to have lots of new growth. New growth is very susceptible to many sucking insects. It's, in the industry, I could see using it. But in my garden, even in my containers, especially in my containers, I wouldn't use it because it would build up so fast it would cause problems with the plant. It can actually cause burning. I burned a field. Well, it wasn't a field, my corn patch.
It gets bigger every time you tell the story.
Yeah, it's like those fish stories, right? I had a patch of corn when I lived in Oregon, and I applied ammonium sulfate, it was ammonium nitrate. I think it was, I don't remember which it was. Ammonium nitrate is not sold anymore in the U.S. as a fertilizer, and that is 20% nitrogen, and I burned the corn. And corn is a high nitrogen feeder. I saw dead stripes in the leaves, and that's what it was from. So it's very easy to do damage to a plant when the analysis of nitrogen is that high in the fertilizer. I'm a little concerned about how dense this plant is. I wonder if she planted a lot of beans. Initially, bean packet will say plant them 2 inches apart in the ground and next to the trellis. But then it usually goes on to say thin them to, in this case, I would think about a foot apart. She may have just too much bean plant there, and the competition when you plant vegetable producing plants too close together, nobody will produce. And so where we're seeing the flowers and the beans is on the end of this scrum of plants where those roots have a chance to go off in their own direction, and the competition is not so tough.
Yeah, you were kind to give them 12 inches of spacing between the plants. I'm looking at the directions for one variety of green beans here, and it says sow seeds about 1 inch deep and 3 inches apart when the plants are a few inches tall. Thin them to at least 18 inches apart, but that's for bush varieties. And for pole beans, and I'm thinking this is a pole bean?
I would assume so. It's certainly grown tall.
All right. Well, and they're saying 4 inches apart for pole varieties. So,
see, to me, that's too close together.
Yeah.
I wouldn't do that. I don't know why they put that on the packet, but 4 inches gives you room for a stem and 2 leaves and nothing more. But even pole beans branch. And so the giving them space so that they can get their own nutrition, and spacing plants so that if you get an insect, the beneficial insect that's going to take care of it for you can get to that insect. There aren't so many hiding places. You don't trap water or moisture or dew or rain in the leaves, which can lead to fungal and bacterial diseases. Spacing plants further apart, almost always, I'm saying almost, but I can't think of a case where it doesn't lead to healthier plants all the way around.
And again, look at the planting space that these beans are trellised along a fence. It's that typical space between a fence and a walkway of maybe 12 inches.
Yes, very little root system space, yes.
Right, and we don't know what was there before or what may be on the other side of the fence as well that may be competing down in the soil.
True. And we don't know. We see there's sun on the fence and shade on the concrete at the moment, but we don't know what time of day this picture is taken or what direction that plant is facing, but it could be getting tremendous amounts of heat from sun, period, but also reflected sun off of the concrete and off of the nearby fence. The fence is less of a problem, but and that heat can lead to local temperatures being above about 86 degrees, 90 degrees, and the pollen in the bean then will not be viable, will not have life, and so the bean will not produce. The flower may occur, but if the pollen is dead, then you will never get a green bean out of that flower.
So maybe, Marion, next time maybe space the beans a little further apart, maybe try it on the fence again, but space the beans a little further apart and maybe dilute that fertilizer you're using to maybe 1/3 of what you may have been using.
Yes. Measure.
Yeah. And maybe that, because too much nitrogen, as we've talked about, can inhibit the fruit production.
Right. And there are certainly lots of leaves in this picture.
Yeah.
So, yeah. Sounds good. I like your recommendations, Fred.
Thanks. I'll send Marion a bill in the morning.
Okay.
Right. But Debbie, you put us on the right track again. Thank you so much for your help.
Oh, always my pleasure. Thank you.
That's Debbie Flower, college horticultural professor, retired. Coming up on Saturday, October 4th, I'm going to be riding my bike. Well, what's so unusual about that, you might be asking yourself? Well, October 4th is the date of the Sacramento Century Challenge. That's a 100-mile bicycling event that goes along the Sacramento River. It starts in downtown Sacramento and heads south through the Delta farmland region and loops back. And yes, 100 miles is part of the challenge. Also part of the challenge is myself. I'm 74 years old, for heaven's sakes. And no, I will not be riding an electric bike. I have plenty of acoustic bikes to choose from. Adding to the challenge will be the route itself. It's infamous for pothole-filled river levee roads, as well as ferocious northerly headwinds that are usually in your face while you're pedaling on the way back. Now, I'm doing this for a very good cause. I'm helping out the Sacramento Rotary Club raise money for the Sacramento Children's Home Crisis Nursery. The Sacramento Children's Home Crisis Nursery is the only program of its kind here in Sacramento County. It directly prevents child abuse and neglect by supporting families with small children at times of crisis. The nursery allows parents to bring their children, ages newborn to 5, for emergency hourly or overnight care and protection during difficult times at home. Their goal is to keep families together and reduce the number of children entering foster care. We're calling this Farmer Fred's Ride for the Kids, and we'll have a link in today's show notes with more information on how you can donate to help out the Sacramento Children's Home Crisis Nursery and urge me onward. So how about it? Maybe you could pledge 10 cents a mile. That would be $10, along with a hearty, "You go, Fred," or maybe a more generous $1 a mile. That's $100 to help give me the mental endurance for this all-day ride. And at my age, I'll have you know, I will take my time, thank you, and enjoy the farmland scenery, and of course try to stay upright on the bike. Again, please support Farmer Fred's Ride for the Kids. Look for the link in today's show notes or at gardenbasics.net. Your support will help provide a safe place for local small children in need. Thank you for your support. Let's go. Garden Basics with Farmer Fred comes out every Friday. Garden Basics is available wherever podcasts are handed out. For more information about the podcast, as well as an accurate transcript of the podcast, visit our website, gardenbasics.net. And thank you so much for listening and your support.